Welcome back to Calculus AB. Today's topic 3.1, and this would be pretty much part 5 and the last part of 3.1. So, what we're doing today, we're pretty much looking at the derivative of the exponential function with base e, first of all. Right. So, again, if you guys recall from previous lessons, the derivative of e to the x is just e to the x, right? It's pretty much the only function that we know of that does that, right? And then the chain rule version for this would be pretty much the derivative of e to the u with respect to x would be equal to the derivative of, it will be equal to e to the u times du dx, right? The derivative of u with respect to x, which is pretty much, again, e to the u times u prime, right? So in this case, it's not an internal function, but it's the exponent that would be considered like your internal function, right? So u, if we look at the first problem right there, we want to find the derivative of each function. So we're looking at y equals e raised to the 2x to the third, 2x to the third power minus 3x. So again, we want to make sure that we identify what we have here. So u, which is our exponent, is 2x cubed minus 3x. And then u prime would be equal, so we take the derivative of that, and that's just going to be 6x to the second power minus 3. And then from there again, so y prime would be e to the u, or e to the 2x cubed minus 3x times u prime, which is just 6x squared minus 3. Let's not forget the parentheses. All right, that's pretty much it. So now let's look at b. So at b, we have u would be 1 over x, or in this case, x to the negative 1. And then from there, so we're going to find u prime. So u prime equals, again, n is negative 1, so it'd be negative x to the negative 2, or negative 1 over x squared. So y prime equals e to the u, or in this case, e to the 1 over x times negative 1 over x squared. Just simplify this a little bit more. So you would have negative e to the 1 over x squared. And that's our y prime. All right. And then sometimes, so again, definition of an exponential function to the base a. So we're not always going to be using base e, right? So if a is a positive number not equal to 1 and x is any real number, then the exponential function to the base a is denoted by a raised to the x and is defined by a raised to the x equals e raised to the natural log of a times x. All right. Now, the definition of a log function with base a. So again, if a positive number not equal to 1 and x is any real number, then the logarithmic function to the base a is denoted by log base ax and is defined as log base a of x equals 1 over the natural log of a times the natural log of x. Okay. So now we look at the derivative of those, and that's pretty much why we use this definition, right? So using these different definitions, and we can come up with the derivative of of these things, okay? So the root of the first one, a to the x, is the natural log of a, which is, again, just the number times a to the x. And then the chain rule version would be the natural log times a raised to the u, so the same thing is over here, but times the derivative of whatever you have right there, okay? So sometimes we're going to be using one, sometimes we're going to be using the other one. So find the derivative of each of the following. So here, if you notice, we just have a equals 2, and then u will be just equal to x, right? So u prime is 1. So you don't have to use this. You would just have to use this part. So y prime equals the natural log of 2 times 2 to the x. And you're done. All right. And then the next one, now we have a equals 2 again, right? So equals positive 2. U equals 3x. So u prime equals 3. So in this one, since I do have a u prime that is bigger than 1, then I do have to use the chain rule, right? So y prime equals the natural log of 2 again, right? Times 2 raised to the 3x times the derivative of 3x, which is just 3. just clean it up a little bit more. Y prime equals 3 times the natural log of 2 times 2 raised to the 3x. All right. And then let's continue down here. Let's see what else. So now using the chain rule, oh, sorry. Forgot about part C here. So part C, again, you guys have the little log base a of x. So that would be just 1 over the natural log of a times x. And then in this case, we do have an internal function. Right here, u is equal to cosine of x. So you got to be careful with that. All right, so let's, using that formula up there, pretty much we just have to find a couple of things and then substitute. So u prime equals negative sine of x. So, and then a here is equal to, right, a is your base, that would be positive 10. And then we already said u is equal to cosine of x. So we start substitute everything in there. So that would be 1 over the natural log of 10 times cosine of x. All right. And then times du dx, which would be negative sine of x over 1. So that is our y prime. Don't forget a label. So sine over cosine is just tangent. So that would be negative tangent of x over the natural log of 10. All right. And then our little next example. Ahora sí. So example 9. So chain rule, again, differentiation using data tables. So again, these are common problems that you guys would see in the FRQ parts, right? So example 9, the value of two differentiable functions, f of x and g of x, along with their derivatives, are given in the table below for several values of x, right? So we have f prime, g, and then g prime. All right, don't forget that. So they're telling us h of x is equal to f of g of x, find h prime of 2. So what we want to do here is first find h prime of x, right? So again, it's the derivative of the outside f prime with the inside intact g of x times the derivative of the inside g prime of x. All right, so this is pretty much, we just have to like do back substitution. So we're looking at h prime of 2. So that's going to be equal to f prime of g of 2, right? We're going to get some number there. And then we're going to map it back to f prime times g prime of 2. All right, so here we want to continue. So g of 2, so f prime of 2, of g of 2, that would be what? Positive 3. So this is f prime of 3 times g prime of 2. G prime of 2 is 3/2, as we have it right there. So times 3 over 2. And now we still got to find f prime of 3, so we map it again. So f prime at 3 is negative 1. So that becomes negative 1 times 3 over 2, which is just negative 3/2. And that's pretty much our h prime of 2. All right, so let's look at problem B now. So we're looking, let me do it up here. So we're looking at j of x. So j of x equals g of f of x. We want to find g prime at 1. All right. So again, first we want to make sure that we find j prime of x. So that's again the derivative of the outside g prime of f of x with the inside intact times the derivative of the inside, which is f prime of x. And now we start doing our substitutions, right? Everything else stays the same. Now we're just writing the number instead of the x, right? So in this case, we're going to be using 1. So we just have 1s right there. All right. So again, I start to find those values. What's let's start off with, so J prime of 1 is equal to G prime of, first I have to find F1. So I go ahead and find F1, which is positive 5. And then times F prime of 1, right? So F prime of 1 is negative 1. So times negative 1. And then the last thing you want to do right there, you can have G prime of 5. So find that one. So G prime of 5 is negative 1 half down here. Sorry. So negative 1 half times negative 1 equals positive 1 half. And that would be pretty much our J prime of 1. All right. So that's pretty much it.